So when training AI, there's a lot of problems because the more data we have, the better our model is, but we're missing a lot of data. If someone only taught you to how to read or speak from one book, everything you know about sentence structures and everything is that one book, and you talk like that one book, you might only understand stuff if it's close to that one book. And if you never saw real world examples of all stuff, you won't really understand what a cup is. You'll just have read the word cup and get the description from the book. Your frame of reference will be lousy, and humans have so many frames. And we learn to associate stuff, like we have this association learning where we see a cup and we instead of know what a cup is, so when we see a totally new cup, we just add it and learn more about cups from adding it. We kind of know what a dog is, so when we associate a new dog, we see new stuff. But the problem with data sets in online is oftentimes they're not extensive or well labeled, and if they're not, the data might be wrong or something. Not only might it be wrong, it might even make the model go off. It might not be just the best data version, because it might be a example of a person, but not the best example of a person. It's not the best thing to train on. Yeah, and then it might be hard for it to generalize. However, if you don't, so you might have either you train in the wrong direction, or it become also hyper-specific. You only saw one example of cups, and you think every cup must look exactly like that. So wrong presence, hyper-specific, or too under-specific, all these problems. So how would you get more data into it without creating huge databases? Here, I propose a new training method that could alleviate some of these problems. Not fully, some of the problems. And that is first to train on a little bit of data to some weak extent that you know well that it works. Very, very well. And I'm going to call that RE. Then, so you train the model on this data. And then after training on this data, you scour a big website or the web where it might not have as good examples of our data, but you sort it out quickly. And you sort it out into yes or no based on your model. Then you train on that data, but much more weakly. And that gives you a lot more data to train with. I don't know why it's flashing there. That gives you a lot more data to train with, but this data might be missed because you're training based on this data. You might have made some of the wrong assumptions that you previously made, or that it might be further away because you might be predicting stuff that's not true. You're guessing and a guess and a guess and a guess. So then you train back on original data, and you use that original data to bring it back to reality, what you know is certain. And you only leave the good, useful stuff from this thing that helped you train back on the original data that you know is certain. Now you can make this, how strong you train on data can also be adjusted by this, where you weakly train it up to extent A here, and that's how strong you train it. You modify it by a constant here. I'm going to call that B. And that might be modify a lot in the right direction or wrongly in the right direction. And here, you train again, but you're going to train it so that it goes total A. So total amount of training in a direction, how strong it needs to change, is based on how much incorrect it gets in this new data set, and how off it is. So that you adjust it. If it's suddenly predicting 50% of this stuff wrong, then here you have to train it a lot harder. So you can make it adjusted, but based on how much this has adjusted is to be wrong. And this gives you more of a dynamic range of adjusting based on parameter fits. When here you're kind of guessing a little bit how much A affects the training. Here you have to do a little less guessing over and over again. Not perfect at all, but a lot better. The second thing you could do is make this compute a lot is by using a computation where you put it, where I'm trying to say some long-term, short-term memory things, is you can make it so it gives out input, and each round it gives out a certainty value of yes or no. And you make it train so it gives out every time you put in the model your data, and I've discussed this idea before, gives out an answer. Then you take some of the computation from before, put it in your model, and say that you already got this answer, and this is the time this model runs, and thinks over again and gives you a new answer. Does it still think it's correct? And so on and so on. This could make it go a lot faster than the argument part, where it could be you going 10 times faster by looking at 10 times more data, which will help get rid of noise and stuff because you're less certain, but you're also looking at more data. Or you can adjust it to different levels. But also in the reality part, you can make it have adjusting that the longer it thinks, the more it gives you a certain value, but it might not give you a faster value, but it also might overfit. It's more like find one pattern that is false too. So you have false patterns and stuff more likely happen, but also it gives you a more certain answer, and it's more likely just, how would I describe it? It's a stronger model when it ever fits. Stronger model means it fits the data points better. It doesn't mean that the data points could be wrong, so you have more of that error. But you also have a model that just fits the data better. And having it also train over and over again means it finding patterns that actually means that it's thinking. It's thinking about it in dynamic time, which is also more likely to find real things. Like if it is looking at language, every time it's thinking, because it has to keep using the same thought process over and over again to some extent, it must be thinking about important factors. So it's more like find factors like every time it's repeating, it looks at mainly how everything interacts with one word, car, which is a subject, instead of everything else. I hope that kind of makes sense. Or it's every time it's repeating it, if it's doing an estimate, it's doing to one more place, visit place. So it's more likely it could be good, or doing the same calculation but just refining it. So it's more likely based on reality. So yeah, all that stuff is just going on. Now, also the advantage of having repeating cycles with augmented cycles, you can sort through the data more quickly. And the first cycle get rid of the clear examples of yes or no. And when you have a lot more data and a lot cleaner, worse data set, speed becomes more of the essence, a lot more, more than if you have a clean data set that you know everything is going to be useful. You want to throw out some quickly in an augmented data set. Well, I hope you found this interesting. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year, and 4,000 watts hours, which is really hard, but with your help, I think you can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Thank you very much. Goodbye.